Okay, so we have 10.1, simplifying rational expressions. Now, putting something in the simplest form is when the numerator and the denominator have no common factors other than 1 or a -1. And sometimes we even would take that -1 out if it's going to help us with the problem. So remember your numerator and your denominator. Your numerator is the one on top, denominator, the down number, is the one on the bottom. So let's look at a problem. So we're looking here and it says simplify. And what I want to know is what can I take out of this problem? I'm going to factor. So when I look at the top, I say to myself, ooh, that one's a 5 and a 10. I can take a 5 out of each of those. This top one, the 5x, is 5 times x. And the 10 is 5 times 2. I'm even going to look at the bottom. If I could take the 5 out of these, I can also, look at that, take a 5 out of the bottom. So now, I'm going to rewrite this. I'm going to, like we were doing before when we were simplifying and we were, when we were factoring. I'm going to take that 5 out. I'm going to cross it off here and here, and I'm left with x minus 2 on top. On the bottom, I have 5 times x. And if it helps you, go ahead and leave it separated by the dot. Because what you need to be able to do is you need to be able to take the 5 out of the top and out of the bottom. And here we have the 5 and a 5. It is 5 times this whole thing. And if we're looking at multiplication, then we can simplify them out. And so my answer is x minus 2 over x. Let's try another one. This one's a little bit more difficult, going back again to chapter 5 where we worked on solving and factoring, factoring. So we're going to factor that top part and factor the bottom. And hopefully then we'll see something that comes out. So to factor the top and the bottom, we're going to make our box. And again, I would really like to see all the little small parts because as we get more and more difficult, they're going to be important. Remember that, and I'm going to start with the top part. This first number goes in this square. The last number goes here, and when I add these two together, I should get 3y. All right, so the only way I can get 2 is 2 times 1. It's the only way I can do it. So knowing that, these two share. And I like to keep it just in a column, that way it kind of always goes that way. These two share the 2, and you'll notice I put them in the same place also. Helps me to organize it that way. Okay, so here we have y squared, which is y times y. We do just like I did before, keep this column the same, these share y, and keep this spot the same, these share y also. And so y times 1 is y. 2 times y is 2 times y. So I got y squared. Do I have 3 y's? Yep, 2 and 1 y and 2. So my factor is y plus 2 and y plus 1. Doing the next one again. Y squared goes here, -1 goes here. I know when I add these two together, I'm going to get 0 because there's no number in the middle. All right, now to do -1, that's going to be -1 times 1. Those are my only way. So again, I can follow this up and go, then I know that one's going to be a 1. I can follow this over in the same spot, and that'll be a -1. Y squared is y times y. Column here, y, and y. Now when I multiply here, I get a positive y, and here I get a negative y. When I add these two together, I get 0, and I have y squared, 0 in the middle, and -1, so I know I'm right. When I'm factoring then, I have y minus 1 and y plus 1. Now we should be able to see that we have something that's the same on the top and on the bottom, and it's multiplication. These are separated by multiplication. When they're inside the parentheses, they kind of act as a single number. So when we see that x plus 1 and x plus 1, we can go, ooh, that equals 1 whole. Something divided by itself is 1. So my final answer is y plus 2 on the top, y minus 1 on the bottom. I cannot take these y's out. because this y is attached to a plus 2 and this y is attached to a minus 1. So I can't simplify those out because they are attached to that. Just like up here, the x is attached to the 2 as well. So we can't pull those ones out. Or we're going to go ahead and continue practicing with solving. And this one, it kind of go back to the first example I showed you, looking at what we can take out here. And you should start looking at the numbers and saying, okay, you know what? I know 12 times 2 is 24. And 12 times 4 is 48. I'm going to go ahead and take a 12 out of everything. So this is 12 times the y plus 12 times 2. And however you want to do that part, if you want to put a dot, you can do that as well. So this is 12 times 4y. Because 4 times 12 would be 48, and then the y. So now you can see every term has 12. When I go to do this, though, I'm going to take the 12 out of the top. And what's left is y plus 2 and 12 times 4y. Now, when you're looking at this, this represents one number because it's inside parentheses. So one number times another number gives me the ability to simplify. They're added together, that's a different story. So when we're all done, we have y plus 7, or excuse me, y plus 2 on the top and 4y on the bottom. This one again is attached with an addition sign, so I can't separate these y's out. So that is my final answer. Now looking at this one, I'm looking at the fact that every single term has what in it? Every term has an x. So I have a feeling I'm going to be taking an x out. When I look at the numbers, I have 2, there's a 1 even though we don't write it, 3 and 2, and there's nothing I can take other than 1 out, and so we don't do that when we are factoring. So let's take an x out. This one has 1x and this one has 2 x's, this one has 2 x's, this one has 1x. So I know it's going to be a single x. So x times 2x, when I multiply those together I get 2x squared plus x times 1, and you've got to have that because if you don't, you might accidentally forget to use the 1 later, and that would be a problem. Here, taking the x out, so here I would need 3x. X times x is x squared, and then got the 3, plus x times 2. So now when we take it out, x on the top, I'm left with 2x, and again I would cross them out, plus 1, x, 3x plus 2. Again, multiplication. This is one number times another. This represents a number. One number times another. So this is 1, x divided by x. So my final answer is 2x plus 1 over 3x plus 2. And I can't take anything else out of that problem. Okay, so now we're working on this problem. And again, there's nothing I can really take out. That should kind of be my worry thing, is that there's nothing I can see. So when I start looking at it, I think about my factoring. And I could factor these. So it's probably what they want. So I'm going to start with the box over here. And yes, they're going to have to make 2 boxes. If you want to learn reverse FOIL and FOIL, there is a FOIL video. And I am more than willing to sit down with you at any time and teach you reverse FOIL, if I think it's going to be beneficial to you and you think it's beneficial. Here I do a squared because the first number goes in the first box, the minus 1 goes in the last box, and I know when I put these two together I'm going to end up with a 0 because there's no number in the middle. To get -1, I need -1 and 1. Follow this up, so this will be 1. Follow this from here to here, here. A squared, we get a times a, so if this column stays the same and this spot here stays the same, then I got here a and -a, so that makes 0 in the middle, a squared minus 1. So when I factored on top, I got a minus 1 times a plus 1. Now I'm going to make a box for the bottom part, the denominator. All right, so again, this is 2a squared, and the last number, negative 1. There's a minus a in the middle, so when I add these two together, I know I want to get minus 1. Or excuse me, minus a. So here, negative 1 is negative 1 times 1. Make that my 1, and make my negative 1 go here. To get 2a squared, there's several ways, but probably the most used way that you'll see is just 2a times a. So again, if we keep our columns and our rows kind of going in the same direction, this would be the 2a and that would be the a. Now what we need to see is, does that work out for what we wanted? Here we get minus a, here we get 2a. Now when I subtract those, 2 minus 1, I get a positive a, and I needed a negative a. That's an easy fix. What if I change this to a plus and change this one to a minus? So now these two share a minus 1. We can even do this. I'm going to step back, take it back to the other part. So back in 3, 2, 1. So we change this to positive 1. That means we need to change this to positive 1. And we change this to negative 1, that to negative 1. So that means this changes to a negative and this changes to a positive. Does that help our problem? Well, here, a times a positive would give me a positive a. 2a times negative would give me a negative a. And negative 2 plus 1 would give me negative 1a. So it fixed my problem, no big deal. So I'm going to put on the bottom 2a plus a 1, a minus 1. Now you should notice the top and the bottom are sharing what? A minus 1. So I'm left with a plus 1, 2a plus 1. And again, I cannot simplify any further because a is attached to the 1, 2a is attached to the 1. So I can't take the a plus 1 out. They all stay together.